When you type youtube.com and hit enter, your computer has a problem. It has no idea where YouTube is. Servers don't have names, they have numbers. Finding the right number kicks off a worldwide relay race that finishes in about 30 milliseconds. By the end of this video, you'll know every step of that race and why your second visit to any site is always faster than your first. Every server on the internet lives at an IP address, something like 142.250 or 120.78. Routers move your data using these numbers and only these numbers. But you'd never remember that. You remember youtube.com. So the internet keeps a phone book that maps names to numbers. That phone book is DNS, the domain name system. Here's the catch. There are hundreds of millions of domains, changing constantly. No single book could hold them all, so DNS splits the job, and the lookup becomes a journey. Before asking anyone, your computer checks its own notes. First, the browser cache. If you visited YouTube recently, the answer's already sitting in memory. No luck? It checks the operating system's cache next, then a small local file called the hosts file. Any hit here ends the journey in microseconds. But let's say this is your first visit. Every cache misses. Now your computer has to ask for help. Your computer sends the question to a recursive resolver. Usually it's run by your internet provider or a public one like Google's 8.8.8.8 or Cloudflare's 1.1.1.1. The question itself is tiny, a single packet, usually UDP on port 53, small enough to fit in one trip. No connection setup, no handshake, just, "Where is youtube.com?" fired into the network. Think of the resolver as your personal librarian. You ask one question, then wait. The librarian runs around the entire library so you don't have to. The resolver checks its own cache first. It answers thousands of users, so popular sites are usually in stock, but we're assuming a cold start. So the resolver starts at the top of the world. The resolver first asks a root server. There are 13 root addresses, mirrored across more than 1,000 machines worldwide, so one is always nearby. The root doesn't know youtube.com, but it knows who manages every ending. .com, .org, .dev. Those endings are called top-level domains, or TLDs, so the root answers. For .com, go ask the TLD servers. The TLD server doesn't know the IP either, but it knows which nameservers are responsible for youtube.com specifically. One more referral. Notice the pattern. Nobody knows everything. Each server just knows who to ask next. DNS is a chain of delegations, and we're one hop from the answer. The resolver's final stop is the authoritative nameserver, the machine that actually holds YouTube's records, run by Google itself. It replies with an A record. youtube.com lives at 142.250.190.78. This answer isn't a referral. It's the truth, straight from the source. Records aren't the only kind, by the way. AAA records hold IPv6 addresses. MX records say where email goes. But for loading a website, the A record is the prize. The resolver hands that IP back to your computer, and your browser can finally open a connection and load the page. Here's the clever part. Every answer carries a TTL, a time to live. It's the record saying, "You may remember me for this many seconds." Your browser caches it. Your OS caches it. The resolver caches it for everyone in your city. That's why your second visit skips the entire journey. It's also why changing a domain's DNS takes time to spread. Old answers live in caches worldwide until their timers run out. So here's the whole story in one sentence. DNS is a chain of servers where each one knows just enough to point you to the next, walked once, then cached everywhere. Your computer got the IP address, but an IP alone loads nothing. Next, your browser has to open a secure connection, and that handshake is its own hidden dance. That's the next video.